Somewhere in the heart of South Florida, a routine maintenance drawdown turned into one of the strangest field discoveries in the history of Everglades restoration. This is the story of what happened when engineers pulled the plug on a stretch of managed marsh, and what came crawling, slithering, and surfacing out of the mud in the days that followed. Every few years, water managers in the Everglades agricultural area schedule what they call a dry down. It sounds harmless enough. Lower the gates, let a section of marsh drain naturally, let the sun bake the mud, and give the native plants a chance to reset. Wetlands need these dry cycles. Without them, invasive vegetation chokes out the natives, sediment builds up in the wrong places, and the whole system stops breathing the way it's supposed to. This particular dry down covered roughly 9,000 acres of managed treatment marsh, part of a decades-long effort to filter agricultural runoff before it reaches the protected interior of the Everglades. The plan was simple. Close the water control structures, let gravity and evaporation do the rest, and send a survey team in after 2 weeks to document how the plant life responded. Nobody expected the survey team to find what they found. The first sign that something was off came from a routine soil moisture reading. Environmental scientist Elena Marchetti, part of the regional monitoring crew, had walked this same transect a dozen times over the years. This time, the ground felt wrong under her boots, spongy in places that should have been firm, and firm in places that should have cracked into the usual dry season checkerboard pattern. She knelt down to examine a depression near the tree line and noticed the mud around it had a strange, almost engineered texture, like something had been packed and repacked over a long period. When she pushed a marking flag into the soil, it sank nearly 2 feet with almost no resistance before hitting something solid. That was the moment the routine survey stopped being routine. Within 48 hours, the district had authorized a full subsurface investigation using borescope cameras, the same kind of equipment used to inspect pipes and building foundations. What they found running beneath nearly a mile of marsh was not a single collapse section, but an entire hidden network. Tunnels, chambers, and connecting passages carved through what should have been solid root mat and peat soil. Some of the larger chambers were big enough for an adult to crawl into. Others narrowed to channels barely wide enough for a camera head to pass through. The engineers on site described it less like erosion damage and more like an underground settlement that had been quietly expanding for years, completely invisible from the surface because the standing water above had always hidden the entry points. Field engineer Diego Ruiz, who led the inspection team, put it plainly in his report. The marsh had been living 2 lives, the one visible from an airboat, and an entirely different one happening in the dark, just below the waterline. As the water level kept dropping, the shrinking pools became a stage for an ecological drama nobody had signed up to witness. Native fish, largemouth bass, bluegill, and shad crowded into the remaining puddles, gasping in water that was heating up fast under the August sun. But mixed in among them were fish nobody wanted to see. Armored, bottom-dwelling catfish with rows of bony plates instead of scales, capable of gulping air directly from the surface when the water ran too low in oxygen for anything else to survive. These fish weren't struggling. While the natives fought for their lives, the invaders simply waited them out, comfortable in conditions that were lethal to everything around them. It was an uncomfortable preview of what the deeper investigation would soon confirm. The marsh's underground infrastructure hadn't just given these invaders a place to hide. It had given them a competitive advantage that the native ecosystem was never built to withstand. Long before anyone found anything dramatic underground, the survey crews had already logged something quieter, but arguably more alarming. Clusters of pale, golf ball-sized egg masses clinging to reeds and fence posts across the drain sections. These belong to an invasive apple snail species that has slowly spread through South Florida's canal systems over the past 2 decades. Each cluster can contain several hundred eggs. Multiply that across thousands of acres of newly exposed vegetation, and the math gets uncomfortable fast. Potentially millions of juvenile snails ready to hatch the moment the water returns. These snails don't just compete with native aquatic life. They strip marsh vegetation at a pace that outstrips regrowth, and they can carry a parasite capable of causing illness in humans and pets that come into contact with contaminated water. It was one more sign that a system designed to filter and protect was quietly incubating the very problems it was built to prevent. 9 days into the drawdown, a maintenance crew operating heavy equipment on an adjacent section hit something that stopped the entire operation. An excavator bucket, digging routine drainage channels, punched into a hollow pocket nearly 5 feet below the waterline. When the operator lifted the bucket to look inside, something inside the cavity moved. Wildlife responders arrived within hours. What they eventually extracted from that single burrow complex over the course of 2 exhausting days was staggering. More than a dozen Burmese pythons, ranging from newly hatched juveniles to one adult stretching past 14 feet, all sharing what field biologists came to describe as an actual den system, multiple connected chambers, shed skins piled in corners, and evidence of repeated, long-term use rather than a single animal passing through. This detail is what troubled researchers most. A single snake taking shelter in a hole is unremarkable. An interconnected system of chambers used across multiple seasons by multiple animals suggests something closer to an established colony, a population that had been breeding and expanding underground undetected for years. Thermal imaging of the surrounding area picked up additional heat signatures deeper in the tunnel network that the extraction team never reached. Conservative estimates from the response coordinator suggested dozens more pythons could be denning. Within a half-mile radius of that single dig site, numbers that, if accurate, would represent one of the largest concentrated python populations ever documented in a managed restoration area. As the water kept receding, biologists watched a phenomenon they'd seen before in smaller drydowns, but never at this scale. The last remaining pools of standing water became death traps for the prey trapped inside them and feeding grounds for everything else. In one depression roughly the size of a swimming pool, researchers counted well over 200 alligators, drawn from surrounding canals by the concentration of easy prey. The water temperature in that pool had climbed into the low 90s, and dissolved oxygen levels were dropping fast enough that the fish inside had only hours left regardless of what ate them first. Veteran wildlife biologist Owen Castellano, who has documented alligator behavior in the region for over 2 decades, described territorial aggression at a level he said he'd rarely witnessed, animals rolling, snapping, and bellowing in a crowded space that offered no room to retreat. Above the water, wading birds descended in numbers rarely seen outside of nesting season, picking off fish forced to the surface by the shrinking, oxygen-starved pools. It was, in the words of one field tech, a feeding frenzy and a mass die-off happening in the exact same square of mud. While the animal discoveries dominated the initial reports, the more consequential finding may have been invisible to the naked eye. Soil samples pulled from the top layer of exposed sediment came back with phosphorus concentrations dramatically higher than the treatment area's target threshold, a legacy of decades of agricultural runoff that had settled into the marsh floor and simply stayed there undisturbed, until the water dropped low enough to expose it to air. That exposure matters. When saturated oxygen-starved sediment is suddenly exposed to open air, the organic material inside begins to break down rapidly, releasing the nutrients that had been locked away. If the area refloods too quickly, all of that stored phosphorus can flush downstream in a single pulse, more than enough to trigger algae blooms in the connected waterways, choking out oxygen and setting off fish kills that can ripple through an entire watershed. Restoration historian Dr. Naomi Alvarez, who has spent years studying the long-term effects of Everglades engineering, described this pattern as an autopsy of a century's worth of shortcuts, pesticides banned decades ago, nutrients from farms that closed down years back, and invasive species that had all been sitting quietly in the same few feet of soil, waiting for someone to look. To understand why a single drawdown could reveal this much, it helps to look at what's actually buried beneath the modern Everglades. In the late 1800s, a wave of land speculation drained enormous stretches of central Florida wetland to make way for agriculture, permanently altering the region's water flow. Decades later, a massive mid-century flood control project added hundreds of miles of canals and dozens of pumping stations across South Florida, an engineering achievement at the time that also eliminated well over 1 million acres of functioning wetland within a generation. Every restoration project happening today is, in a very real sense, working against the accumulated weight of those decisions. The stormwater treatment areas built to filter modern runoff before it reaches the protected interior were designed with the best available science. But nobody fully anticipated that they would also become ideal, undisturbed habitat for invasive species that thrive in exactly the conditions a slow-moving, seasonally managed marsh provides. Buried in all of this unsettling news was something researchers hadn't expected. Signs that the underlying ecosystem still remembers how to heal itself. In sections where the drawdown pattern closely mimicked a natural dry season, biologists documented a meaningful drop in invasive plant coverage and a corresponding return of native sawgrass and spickerish, species sprouting from seed banks that had lain dormant in the soil for decades, some dating back to before the mid-century drainage projects. Nobody replanted those seeds. They were simply waiting. Dr. Alvarez described the moment her team realized what was happening as one of the more hopeful discoveries of her career. Proof that even after a century of disruption, the marsh retains a kind of ecological memory, ready to reassert itself the moment conditions allow. Native crayfish and grass shrimp populations rebounded in several of the recovering zones as well, small, unglamorous creatures that form the base of the Everglades food web. When they return in force, wading birds follow, and the broader system slowly starts to stabilize from the bottom up. In the aftermath of the python den discovery, wildlife agencies began using burrow patterns identified during low-water surveys